Okay, welcome to Root Labs at Lunch. Today we have Gilles Henry on methodology as code in machine learning, how to work together as a machine learning team. Gilles is a senior data engineer at DataRoots and also certified. You didn't put it on the slide, Gilles, I see. You're also certified in, I know, in Google Cloud Platform and maybe other things as well. So Gilles, it's up to you.
Thank you, Bart. Okay, let's get to the cheese. So often in machine learning projects, you see there are different components that all have their significant importance. There is, of course, the AI part, which we're focusing on today. So it's really the machine learning part. It's often a model or a pipeline that can generate predictions, whether in streaming or in batch. But this model needs some input. So there's the data pipelines that feed the machine learning part. And these data pipelines need to be tested, they need to be scalable, etc. Finally, this model needs to be exposed through a final interface. And there you can be really creative. So it could be an API, it could be sending an email, it could be inserting rows into a SQL table, it could be whatever. And these three blocks, of course, are driven by business and supported by the infrastructure that you can use. So there you can think of the cloud, for instance, but it could also be some local clusters that you have at your organization. So as I said, we'll focus today on this part, on the AI part, and we'll check how a standard approach can facilitate and ease the development and deployment of your models. And this to make it easier to integrate this part in the whole picture. Another way to look at this was proposed by Scully et al. In 2015. It's just to highlight the complexity surrounding machine learning projects. And this complexity is there, so it's important to take this complexity into account from the start. Okay, so typically you'll want to follow some sort of process, a standardized process at your organization. But this process is not code per se. It's more it's an idea. It's not written, and you still have tons of flexibility around the technology that you use, the project management choices that you make, but you just want to follow this process. And as you can see, we distinguish two parts of this process. There is the development cycle and the deployment cycle. And here it's really important to take the deployment cycle into account from the start, because you need to keep in mind that eventually it should happen, unless there is no value, of course, in the model. But so the sooner you start taking this into account, the better for your project. And so if we follow this diagram, typically you'll start here. You'll start by getting some insights about the business problem you're trying to solve. You get some data. You'll do some data discovery, some data wrangling, probably build a few features. Then you'll run some analyses. Maybe you'll build the first model that you'll validate with the business, and so on. So this is really an iterative loop. But ideally, this loop should also be integrated with the deployment cycle. And in the deployment cycle, you want to publish your results. So publishing like your model through an API, for instance. And you want to gather some insights about your published model. You want to run some application integration, some testing too, and to finally get your model in production. And if you have these two loops intertwined, hopefully you'll be able to apply some continuous improvement, meaning here you might build new features and integrate them into the model that's running in production. Now, as I said, this is not coded. And so here is the question now, how could we increase the probability of our success? How can we make sure that the team follows some standard practices that are common to your organization? Imagine there is a team change, someone leaves, unfortunately someone dies, could happen. Well, this shouldn't impact your process too much. You your projects, your machine learning projects at your organization. So meaning if there is a new project, it shouldn't be all new. You want to kind of lay the foundations of every project, a bit like class inheritance in object-oriented programming. So here with methodology as code, that's something we'll try to actually provide. So if you think about a few characteristics that you'd like to have, it could be a long-term vision. How are we going to build sustainable code, a sustainable solution base that can be deployed? How can we make, well, have a consensus about how we'll develop these data pipelines and these machine learning solutions? How will we minimize the time and the costs for new developers? So if someone new joins the team, should they be like learning tons of things, or should they already adopt the common practices you have at your organization and be ready to contribute from maybe the first week? And this, all of this is really to have a robust and mature starting point. So if we think more about, well, code concepts or software engineering concepts, this might lead to like clean contracts with the underlying systems and consumers. So if you remember the first slide that I showed you with the different pieces of the puzzle, you see you want to make sure how we're going to integrate this is clean and is respecting some agreements with, I don't know, maybe operations or some other teams that are working on the same product. So this is yeah, very important. You might want to have some declarative config files for to automate the setup of your project. You want to make it easy to deploy something on the cloud. So meaning you've been developing locally or remotely on a cloud, you want to make it easy to get this thing actually running in production. This leads to the next point, of course. You want to minimize the divergence between what you have been doing, developing, and what's running in production. Ideally, you want to have some full cycle auditability in place, especially in some domains like finance. You want to be able to scale up, meaning, for instance, if you have an e-commerce, you get more traffic, you get more requests for your model, it shouldn't be an issue. And you want to have some CI/CD and some tests, so you're sure everything is running well from a robust point of view. So this is from a high level point of view what we'd like to have in our code base, so in the methodology as code. And now I'll do a partial demo with some technologies here. So we'll be using Docker. This is not a constraint, but it allows you to make sure well, you have some portability, you have some scalability, and like you won't have the issue of someone telling me, oh, it was running on my machine and now it's not running on yours. I don't know what's going on. This shouldn't happen unless they don't have Docker. We'll be doing this in Python. So the code that we built was built for Python, but we have something similar in R. The concepts stay the same. We'll be using Git. And here, to me, Git is, well, you need it. I think you cannot really avoid it. These two, well, this one is optional. This one could be changed to something else. But Git, I mean, if you want to work with a team, there's no better way around it, in my opinion. And the platform we'll be using is Microsoft Azure. So there we'll use their infrastructure to build what we want. We'll cover some concepts, but not everything. For instance, we won't cover the auditability too much in the demo. But I hope you still enjoy the demo. So what will we be doing? It's probably a problem you never encountered. It's predicting iris species. So we have 3 different species that are here. And in our data sets, we'll have 4 different features. So the sepal length and width and the petal length and width. So this is the goal of the project. So now I'll take you to some concrete things. Okay, so I told you we were, maybe I can zoom a little bit. We were using Azure for the infrastructure. So you see we have a Kubernetes cluster running. We have a container registry on Azure for our Docker images. We also are using some Git repo that's hosted by Azure DevOps. And there you see we can have different pipelines. We have the code base, etc. So now let's go, well, maybe I can already show you that we have something already running. So here we're not starting from scratch. We'll imagine that the team already worked something out and that it's working. So here's our API. We can test it. As I told you, we have 4 features, but the team already created a 5th one. And so here we can execute a post request and get an answer. So this is running on Azure, but I'm calling it from my computer, so from my network. Okay, now that you have a better idea of the infrastructure, let's go to the actual code. Here I'll zoom a little bit too, just in case you're watching this from your smartphone. I hope you're not, but I don't know. So here, this is really a reusable code. So it's like a template that already implements all the building blocks that we have. There are different parts, and basically for this project, we applied this methodology as code from the start. We removed a few components just for the sake of the demo, but this robust start is available for all new projects. So setting this up took me less than an hour. And you can think of methodology as code as some sort of cookie cutter template that we adapted to our machine learning projects. So I'll go through the different pieces here. So from the top, you could have some data locally. This one be committed to the repo, the Git repo. That's why it's more gray than white here. But for some local development, this could happen. The data could also be ideally on some server, some SQL server, or whatever makes sense. We have some Docker functionality here with a few Docker files. We have some manifests, that's for the deployment. We have something about models. This could be the models that you build, some metadata about the model, and there typically you can have some traceability, auditability that's in there. That's an option, but again, pushing models to the repo is not, in my opinion, the best idea. Then, of course, you have your favorite tool, notebooks. So it's really JupyterLab notebooks. We have an open API thing here. This is really to describe the API that we built. Let me just help you. So you see, we'll have the specification of the API, what we're expecting and what we're providing. Okay, then we might have a few scripts to interact with our code base, something to build an API, something to do predictions, something to do some integration run. And here you have the source. So the source is really the part that contains the application code that has been tested and validated by the team. So for instance, if we look at the different pieces here, you have helpers, some model functionality, but if we go to the ETL part, there is the team has worked, so it's, on some functionality just to generate the data, okay? And this, you don't really need to look at the code, but this means that other members of the team will be able to reuse this validated and tested code to build further functionality. Okay. Then we have, of course, some testing for the source code and a few files here. So Docker ignore file, Git ignore file, some Azure pipelines, YAML, that's really for the CI/CD part. Docker Compose to run our services, a make file that shows you, it tells you different make commands that you can use. Maybe in your Docker Compose, your Docker images, you'll interact with these different make commands. so they're already, wait, and there is the meetup thing there. Okay, a README for documentation, the requirements, typical file for Python projects, some setup and some docs ini. So this is more for linting, etc. So now that you have an idea of the structure of this Git repo, we'll go through a typical workflow of a data scientist or a machine learning engineer. So here, typically, you're on master. So I'm on master here. And I'll think, okay, I want to create a new feature. So I'll create a branch new feature. And then maybe I want to run some Jupyter notebooks to have a look at my ideas and to implement my ideas. So here I'll use Docker Compose locally to build a Jupyter Lab server or a container running Jupyter Lab. You see everything is cached, so you don't have to wait. And I'll go to my Jupyter Lab container. Here we're already seeing a few notebooks that my team probably worked on. So someone worked on the exploration of the data, but they already used, as you can see, source code. So they imported the generate data sets functions from there. They might have looked at a few things. This is not very well documented. So I'll probably tell that person that I'm not very happy with their documentation, but they created a feature, great. And probably they included this function into the source code as well to build that feature. And indeed, if we go look at here in the source code, we see there is a function here, and it's probably been tested. Indeed, there is some testing. Okay. And now here I am on my new branch, and I'm thinking, I'm not sure this is actually doing what it should. I'll modify it myself. I'll say, actually, I think they wanted to put a minus here. But before I commit anything, you know, I might want to run some local tests. So here I'll just run the test container. So it's just another command. It's also in cache. And we're running the tests. No, I broke the code. Okay, that's not good. So I'll put it back. You know, it's a stupid example, but it's just to show you that there are some safeguards here to make sure whatever you push. And well, here I'm running the test locally, but of course you could have this as part of the CI/CD pipeline. So running these tests and rejecting whatever you did. But now, since we want to add a new feature, let's say here we're doing, what are they doing? They're just doing the addition of 2 columns. So that's the new feature. But I'm thinking, after a notebook that I created, let's say, that actually I want to run, I want to create a new feature where I do the multiplication. Okay. Again, I can test my code, and here we'll see that my tests should run. So it should work, but the test coverage should be lower. So I'll be a bit disappointed with myself. I'll probably add, you see here in the test coverage, in the features, we're covering 78%, but we're not covering the new feature that I built. So I want to add a new test case here. Oh, wait, no. Here, just to make my teammates happy. Okay, I think this is all right. I need to import the function that I put in the source code. Okay, and now let's see if this makes sense. If it's not breaking the tests I had in mind. All that I just added. And just be patient. So it's running fine. So I'm happy with myself, and I think the team might like it too. So I'll add my changes. I'll commit them, new feature multiplication, and I'll push this to my repo on Azure DevOps. okay, I'm happy, but now probably I want to create a pull request that will integrate these new changes. And so just to complete the workflow, I wanna, yes, so this is the branch which is added, create a pull request. I'll go into master because we have a simple flow. I won't say anything to my team. As you can see, I'm the only one in my team. So I'll complete this workflow. And this, you remember when I showed on the process that we wanted to follow, so to ease your pain here, that we want to be able to publish this easily and to integrate those changes. Well, here, if I complete this, so there are no real safeguards, you know, I could have done something really stupid, but I'll just complete it, complete the merge, and this will trigger a new pipeline on Azure DevOps. So there it is. And here, oh, sorry, wrong click. Here you can see the different stages of this pipeline. So here we might want to add some integration testing and other components. Maybe we want to have some more security or whatever makes sense. But you'll see it'll be building and it'll be deploying to my Kubernetes cluster. And that finishes my workflow as a data scientist. So it'll deploy a new model and will be done. So that's what I wanted to show today. So I can go to the last slide of the presentation and put it in big. There it is. I hope you enjoyed it. Thank you for being here. And yeah, if you have questions, I think now is the right time to ask them.
Thank you, Gilles. Yeah, so any questions? I think you can all unmute yourself and feel free to ask any questions. Also, next week, Gilles, you will have a session on Kubeflow. That's correct?
Yeah, correct. Yeah. On Tuesday, same time. Yeah. Be there.
Yeah, okay. And then so the recording of the session will be on our YouTube channel. Also, I will post it in the meetup of this event. And yeah, check our meetup page for any other sessions of the Root Labs.
Great.
So should you have any questions, you can also post them on the YouTube channel below the video. Okay. Thank you all for joining, and I hope to see you next time. Thank you.
Thank you, Bart. Thank you. Bye.